Like to start tonight in talking about Danskammer's role in New York's energy future. There isn't a debate anymore. We know that climate change exists, and we think it's important to strive for as many zero emissions energy sources as we possibly can. But what's also not debatable is the need for natural gas for the foreseeable future. Now, I've heard that some of our project opponents have been saying that coal is actually better than natural gas, and that statement is a little bit astounding to me. I'd like you to take a look at the next slide. This slide clearly shows that there's a huge improvement in air quality, and NASA attributes that directly to a switch from coal to natural gas from 2005 to 2016. This does not mean that Danskammer thinks that we should stop striving for cleaner energy sources, but it does serve to remind us that natural gas has been a huge step forward for us. This information will be important a little bit later in my presentation, so please keep it in mind. Step one was we remove coal. Now, the next critical step in all of this is to make sure that we make our existing energy infrastructure as efficient and clean as possible as we build out the state's renewable portfolio. Next slide. Now, with an eye toward New York's energy goals, we see Danskammer's future in three separate phases. First, we reduce emissions by installing more energy efficient, cleaner gas infrastructure. And second, we hope to transition to 30% hydrogen around the year 2030. Hydrogen, by the way, is zero emissions and would further reduce the amount of natural gas that we would need to use. Third, we would become a 100% hydrogen facility, hopefully by 2040. I'll talk more about this hydrogen piece a little bit further down in the presentation, but I wanted to show you how we could also help further New York's climate goals. But I'd like to start with the natural gas portion of our phased approach, because there's a big misconception that Danskammer is building a massive fracked gas expansion. Danskammer is a customer of Central Hudson, just like many of you who are watching tonight. And that gas comes into your homes, also comes into our facilities. Central Hudson gets its gas from Iroquois, Tennessee, and Algonquin pipelines. But all those pipelines are interconnected throughout our country. And for any gas user to decide where their gas is coming from is a pretty difficult thing. So what we can tell you is that the gas in the pipeline, if it's fracked or it comes from traditional sources, it looks exactly the same once it hits the pipe and it comes into your home. Now, the technology that will be used for Danskammer is the cleanest technology available for these facilities. This slide right here shows just how much more efficient the new Danskammer would be than the old one on a per kilowatt hour basis. Although the new Danskammer facility will operate more hours per year and the total annual emissions for the local region will still be reduced because the older plants have similar emissions that are running in our region right now to the old Danskammer on the left side of this bar chart right here. So they would stop running, the old Danskammer would stop running, and none of these would run possibly at all if a new Danskammer is installed. The next slide will show you, it will take it a step further. So the new facility, we'll break it down. If you look at those numbers in the far right that are orange, it will show you just how much of a regional reduction that you will see if a modernized Danskammer is built and we upgrade our current infrastructure. And like I said, it will stop us from using some of the older facilities that are out there. In this region, if you go to the next slide, you will see that there are multiple old, dirty facilities in this region. You're probably asking yourself, how is it possible that if this facility runs more, it's cleaner? Well, that's because Danskammer would help offset and replace older power plants that are more than 50 years old in this region. It's also going to replace out-of-state coal that you might not realize that we're still using to power the lower Hudson Valley. So the use of a new Danskammer would replace that coal power, which is one of the biggest creators of smog, sulfur dioxide, and soot. And I showed you in that NASA satellite earlier on in the presentation, those things are the biggest contributors to asthma and other health conditions, not new natural gas facilities. So I just threw a lot of statistics at you about tons, and I'm sure you're wondering what all of that means. Let me put it into some context for you on the next slide. One passenger vehicle emits 4 to 5 tons of carbon dioxide a year. So if Danskammer is reducing regional carbon dioxide emissions by 332,000 tons each year, that's like removing 50,000 cars from the road, or in essence, adding 50,000 electric vehicles to the road. Now keep in mind, this number is on an annual basis. So if you compound that over a decade, you're saving the earth from millions of tons of pollution over that decade period. So how can you not install this new equipment at Danskammer? It seems like a no-brainer. Next slide, please. One of the things I think we must point out about this is that the new plant can save you money. I wanted to make sure to point this out because a new Danskammer, as we've said in the past, would use half of the natural gas that the current facility would use, and that would go directly to your pocketbook. Based on the predicted energy consumption for the year 2024, this chart illustrates for you the savings for the Hudson Valley and for the state of New York. Slide 24. Here's an energy fun fact for you. So I'm going to take you back to your 7th grade science class really quick. I'm sure you've heard of hydrogen, but what you probably didn't know is that hydrogen can be used to generate energy. And in addition to that, it's a zero emissions energy. So this can be done if you use wind and solar, and that would be called green hydrogen. A new Danskammer could be fitted right now to run on zero emission hydrogen. Let me give you a simplified flow chart. This is an oversimplified way of putting it, but it simplifies it for our audience. A good portion of wind occurs at night. It's quite windy and people aren't using much power. So it's either dumped or, as we say, curtailed. This causes the renewable owners to lose a lot of money, and it's a waste of our potential energy. So if we could harness that unused power and combine it with water, put it through an electrolyzer, it would create hydrogen, and then it could generate some power. The only byproduct, by the way, of hydrogen is oxygen emissions, and that's actually good for the planet. So immediately a new Danskammer would be able to run on zero emission hydrogen from day one. But right now the problem is that there aren't enough renewable resources to pull from to get that hydrogen, and transportation of hydrogen is still quite the challenge. But we do get the question a lot, how could you fit into the state's new energy goals under the new climate legislation? And this is the answer. If they figure out the challenges related to hydrogen in the state, we could run on hydrogen and be zero emission. Next slide. Now, I want to point out, Danskammer did not come up with this hydrogen idea. It's been out there for quite some time, and it's been in the news lately if you've been paying attention. Hydrogen energy is something that a lot of states are paying attention to now as they start to grapple with how to address climate change and emissions in their state. And on the next slide, you'll see that the president of the New York ISO is also drawing attention to the fact that we need power generators that can be on call when wind and solar are not available. And you can see here in his quote that he points directly to hydrogen as a possible answer for that. Wind and solar are certainly part of our energy mix in the state of New York, but so I don't want anyone to think that we're opposed to renewables, but I think it definitely needs to be reported that there's a lot of analyses that have been taking place lately that show there need to be backup. This slide's a snapshot of wind performance in New York for a week-long period in July of last year. It was an extremely hot week. And you can see here that the wind drops off completely for about 36 hours during the hottest week of the summer. Without a reliable on-call resource to back this up, it could be dangerous on the hottest days of July. There are lithium batteries, and they are improving that technology, but that backup right now only lasts for 4 hours. So it's not the only answer. We need other backup to be on call when a snapshot like this occurs. And again, this is not an argument against wind and solar, but I do think attention needs to be drawn to the fact that there are significant challenges associated with building out renewables. Right here is a picture of 1 square mile of solar panels, and you can see that this is about 75 megawatts of power when the sun is shining. There's a solar farm being proposed up in Cayuga that's 3 square miles, so it would be 3 times the size of this. It's a third of what Danskammer would be capable of producing. It would produce 200 megawatts, again, when the sun is shining. So keep in mind, solar only produces 15% of the time. The pie chart to your right there is from the New York ISO's website, and it shows how much power can actually come from renewable sources. And you can see that solar is 14% and wind is 26%. So if you build a 100 megawatt solar farm, you'll get about 14 megawatts of power from that. So it means if you truly want 100 megawatts of solar, you need to overbuild. So again, not saying that these shouldn't be a part of our energy portfolio, but they certainly come with some challenges. And our facility could be there to step in and help address some of those challenges as we build out. So this concludes my portion. Todd, I want to thank you again for hosting, and I'd like to pass it over to Gavin Donahue now.